Hello everyone. So today I'm going to demonstrate angle between curves. So what we will do is we will do this manually using derivative first of all, and then we will measure it using GeoGebra, measure the angle between two curves. For that purpose, I need to take one question, for example. First of all, I will do the basic settings for this GeoGebra. So I'll go to graphics and then I'll use the default view. And then I also need to increase font size. So for that purpose, I will go to option. I'll go to option and then in option, I'll get font size and then I will increase up to 18 point. Also for this input, I will bring this input in the upside. So for that purpose, I just go to view and then go to layout and then I will set the screen, set the input bar in upside. I'll close this one. Okay, first of all, let us type one question, angle between curves. So we need two curves. So I'll go to slider, I'll go to text, and then I'll type a question here. So I'll write find the angle between curves of the function. Find the angle between curves of the function. Let us say y equals to 8x, y equals to, let's say y equals to 4x square minus 4. One is x square minus 4. And another one is y equals to x square minus 8x plus 12. Should do fine. So we have already typed the formula, the question here. Let's see. So this is in the latex file, so I don't need latex for this one, and then I'll just uncheck. And I get the question here already. Find the angle between curves of the function. So I'll uncheck. Right, okay. So I think I need latex. So for that purpose, what I will do is for some part, I will write in latex format. Y equals to x square minus 4 is one curve. And another one is y equals to x square minus 8x plus 2. Find angle between curves of the following function, y equals to x square minus 4 and y equals to x square minus 8x plus 2. So first of all, we will do manual solution for that. For that purpose, we will just write here solution. Enter solution. In solution, first of all, we need point of intersection between these two functions. So for that purpose, we will just equate two equations. We will just equate two equations, which is x square. Let's write $x square minus 4 is equals to x square minus 8x plus 12 bracket close, and this will give us point of intersection. So let us write, this will give us x square will cancel, and then we will get 8x equals to, we'll get 8x equals to 16. 8x equals to 16. We'll write in dollar sign. Let's see what happened. X square minus 4, so solution, x square minus 4 equals to x square minus 8x plus 12. So this x square will be cancelled. And then 8x will be 12 plus 4 is 16. That implies x equals 2. Let us add x equals 2. That implies x equals 2. X equals 2. So when you input x equals to 2 in this equation, you will get y equals to 0. So the point of intersection of these two functions will be 2, 0. So I will directly write point of intersection, and I will write POI. I just want to demonstrate this in GeoGebra, so all the process is not that important, but I just want to compare two values. That's why I'm doing it manually. So this implies, let's write, when x equal to 2, y equals to 0, right? So I'll write this as POI. Right, therefore point of intersection equals x is 2, and when we put x equals 2, we get y equals to 0. 2, 0 is the point of intersection. Let's see what happens. Okay, we already got point of intersection, which is 2, 0. Okay, next we have to do the derivative of first function and derivative of second function, and then we will calculate m1 and m2. So we need m1 and m2 to calculate the angle between the curves. So first of all, we will do the derivative of this function, y equals to x square minus 4. So let's write here, continue. Derivative, I'll just write y dash. Let's write y dash. I'll write y dash, y to the power dash equals y dash equals x square minus 4 is so 2x, right? 2x. Derivative of x square minus 4 is 2x. That implies y dash is 2x. So y dash, if we put the value POI 2, 0, if we put 2, when x equals to 2, what happens? Y dash will be 4. When x equals to 2, that's right. When x equals to 2, y dash equals 4. Just put the value of point of intersection in this equation, and then you will get, when x equals to 2, we get 2 into 2 is 4. Y dash is 4. So m1 will be m1 and m2. We need two slopes, and for the gradient we did derivative. So I have done this already. So m1 will be value of 4. m1 is 4. Let's see what happened. Okay, so here I think there is some problem here. So y dash equals to 2x. This is right, y dash, no need power, double power, right? Y dash equals to 2x, and that leads to y dash equals to 4, and let's write slash to m1 equals to 4. So this should be fine. Y dash derivative of first function 2x, and then if I put point of intersection at this x, the value of x, if I substitute 2 here, I will get y dash equals to 4. So that implies m1, or first gradient slope of first curve, m1 equals 4. So let me make this bold so that it will be more clear to see. Let me make this one bold. I will go to object properties, and then I will go to text, obviously, and then I will do bold. I'll make this bold. I think it is more visible now. And now we will proceed further. We'll double click here and then we can continue. Now we have to derivate second function. We have to derivate second function, and so I'll just write y dash equals for another function. I'll just denote with same y dash x squared minus 8x plus 12. So it will be 2x minus 8 is the derivative, 2x minus 8. So if I input 2 in the place of x, so I'll get y dash equals 4. Y dash equals 4. And so second gradient, or the slope of the second curve, m2 will be minus 4. This will be minus 4 because 2 to the 4 and 4 minus 8 is minus 4. So m2 will be minus 4. Okay, so we have already got m1 and m2. Now we can calculate tan theta. We can calculate tan theta easily. So tan theta is m1 minus m2 divide 1 plus m1 into m2. So we'll write it directly, tan theta. So for that purpose, I'll write tan theta. I'll just write theta slash theta theta, and theta equals tan inverse, tan inverse. I'll have to write for the power. I'll have to put it in bracket so that it will go tan inverse. It will become like tan inverse m1 minus m2. So I'll need a fraction first, that backslash frac, and I'll write in bracket, so numerator and denominator. So that will be bracket. First will be numerator. So m1 minus m2. Let us write underscore m1 minus m underscore 2. So this is numerator, and the denominator is 1 plus m1 plus times m2. 1 plus m1 into m2, and this will give us theta equals 28.04 degree. So you can do the calculation here. I'm going to write result directly so that the video will not be too much lengthy. It's not that good. So let's write theta equals to 28.04, and this is degree. This is degree. .04, and I'll write it in power. Oh, this should work. Let's see. Okay, just a minute. Did something wrong here. Maybe we can directly write 10. We can directly write 10, or we have another solution. There is not one solution for a problem, right? There may be many solutions for a problem. I think it must work, and I am going to make this work. All right, here 10 small should work. Okay, theta equals 10 versus m1 minus m2, 1 plus m1 into m2, and theta is 28.04 degree. So we have already come up with the solution. The angle between two curves, theta 28.04 degree. So I think now we can make this a little bit smaller. Small. Okay, it is already small. Okay, and then let's put it somewhere else. We will demonstrate. Now we will demonstrate. We just need this much. For now, we just need this much, and we'll now start inputting the curve. Let's bring two curves. One is y equals to x square minus 4. X square minus 4, and another is y equals to x square minus 8x plus 12 plus 12. So we have already got two curves. Now we just need angle between these two curves. So here is gradient of first curve, here is gradient. We have already calculated m1 and m2, and then we have used this formula tan inverse theta equals to tan inverse m1 minus m2 1 plus m1 into m2, and we have got theta equals to 28.04 degree. So this is the angle that we have calculated here. So we will measure this using this GeoGebra. Let's measure. So for that purpose, what we need is let's go to segment. We need one line segment here. This is a 2, 0. This is point of intersection, right? We have already calculated point of intersection is 2, 0. So we'll calculate here, and then make it as small as possible. Should work fine. As small as possible should work fine. As small as possible should work fine. Okay, just a minute. Okay, so I'll make it as small as possible. As small as possible. I'll make it as small as possible. And same here. So I will again go to segment, and then, okay, just a minute. Disappear. I'll bring it down here. So first of all, what I will do is I will remove this label. You will remove this label, and I will remove this label. And then I will also remove this label. So next is what I will do is I'll go to line segment again, and then from here, from this point right here, I will from this point, not that point, I'll go to line segment, and then I'll click on this point. I'll click on this point, select line segment, and then I will click on this point. I think now I can get it. I'll click on this point right here, and then I'll go up to this point. So now we are ready to measure the angle between these two curves. Let's go to angle here, and then we will click on this point and this point and this point. So it is 28.09, almost. We got almost very close. We get very closer value. We get 28.04 from measurement, from manual calculation, and we got 28.09 degree by using GeoGebra, measuring using GeoGebra. So I will bring to normal view, bring this to normal view, and then I just don't need grid, I don't need axis. So I have already calculated angle between curves, and I just don't need this point. I don't need this point. I need this angle. I don't need this point. I don't need this point. I don't need this point. Okay, this point maybe I need, because this is point of intersection, right? So maybe I need this point, that point. And I also need these two curves, but I don't need their labels. So I'll go to right click them and show label, and then I will go to uncheck show label. So I also don't need this one, alpha or whatever it is. I'll go to angle and then show label. Oh, sorry, So object. Okay, but I think I need this one, 28.09 degree, and from here I get 28.04 degree. I can make it more accurate, but this is how we measure the angle between two curves using GeoGebra and using by calculation using derivative. I hope you like this video. And furthermore, what we can do is we can also change the background color, and then we don't need this one now. Let's decorate a little bit, and then I think we just need 1 to 2 minutes for this one. Okay. I'll do this one here, and then I'll move this one. I'll move this one a little bit here. This should work, I think. And what else I can do is I can change the background color. I can change background color. I can go to advanced, and then I can go to preference, and then I can change the background color from here, go to color, and then you can choose any color if you like. Maybe I can choose this one, should do fine. Okay, looks good, right? Anyway, so next is I can also write my name over here. So I have prepared this one, right? So I deserve. So my name should be over here, should be fine. Prepared by is my name. So okay, so I can keep this here, should be fine. And so we can teach the angle between curve using derivative, and then we can present this one as a practical, so which I have been doing. I'm doing this one for my Bachelor in Technical Education civil group for my students. So I think they enjoy doing this as a practical and visualizing the angle between curves. Okay, so this is the point of intersection. I think I don't need to label this one because this is 2,0, so I think this is clear. And then for the other applications, next I'm going to post another video very soon doing maxima and minima also in GeoGebra. So this is the question. Okay, so this much for now, and then for more updates you can subscribe my channel also, and then whatever new idea I come up with, I will make a video and post it over there. But I'm not promoting anyway, so this is for teaching and learning purpose. Okay, I'm going to sign up now. Thank you so much for having patience.